Welcome everybody. This is the last lecture on futures, and what we're going to do here is we're going to look at promises, which are a way to create futures where you can set the value, the result of the future from the outside. Okay? Let's again look at the code that I left you with last time. Defining filter on future. So filter takes a predicate, returns a future. And so what we do here is we create a promise, and we'll talk about the signature of the promise soon. But we create a promise. Then what we do is we're going to kind of wait for this to terminate. We do that by giving it a callback. If it fails, well, the thing has failed, so the future that we want to return, p.future down there, we are going to complete that with a failure. Okay? When this succeeds with a value x, now we have to check whether the predicate holds. If the predicate holds, then we succeed. So what we do is we complete the future with success, with value x, and otherwise we will complete the failure with a new failure exception. All right? So here you see that this promise is something that has a future. You see that there on the last line, p.future. And it has a way to complete the future that I hand out. And the picture I like to draw for that, and the picture I want you to have in your head, is a promise is a little bit like a mailbox. Okay, so a mailbox is that somebody can put something in the mailbox and you can wait for the mailbox. So there's a little sign on the mailbox. That's the signal that your callback has been processed, and then somebody, the postman, puts the mail in your mailbox. And that's exactly what a promise is. It's a little bit like a mutable variable. Where one side is a future where you get the value via callback, and where you can set the mutable variable on the other side. And that's maybe the reason I'm not such a big fan of promises, because it's a very imperative concept. Now let's look at the trade, so trade promise. So a promise has a future. You can complete a promise using a try of t, and then you can also try to complete it. And the problem is that you cannot, it's a mutable variable that you can assign once. So if you would try to complete it twice, bad things will happen. So you can use try complete, and then it returns a boolean that tells you whether or not it has succeeded. Okay, and there is the, remember, the trade future. And so the thing that you pass in into complete or try on complete is actually the value that gets passed to the callback. Okay? So I think this is a very intuitive picture of what a promise is. It's like a single assignment variable where you get the result via a callback. Let's show an example of a future where we're going to race. So we're going to define race that takes two futures, and we want to return a new future, and that is the first future that will kind of successfully or unsuccessfully terminate. So what do? We create a new promise. We register a callback with both futures that try to complete the promise, and then we return the promise. And notice that we use try complete because we're trying to complete that same future twice, and it's a single assignment mutable variable. So you can only, if you would use here complete, one of those two would throw. So that's why we use here try uncomplete. Okay, and of course there's simple helper functions. Instead of creating a try explicitly, you can kind of complete it with success of a value, or you can complete it with a failure. So these are simple helper functions. Let's implement zip using promises. So zip takes two futures, and what it does is it tries to zip them. When one of them fails, the whole thing fails. When both succeed, you return the pair with the two values. And this zip here is a little bit different, that instead of returning a future of pairs, it will take a function that receives the two values and returns the result. And that is, then you don't have to do pattern matching. So this function could also be called zip with, and it could be curried. But it doesn't really matter what the signature is. We're interested in the implementation. So what do? We allocate a new promise, a promise of R. Then we wait for this to complete. If it fails, then we complete the promise with a failure. If it succeeds, then we look what the other future does. And then if that completes, we look at whether that's a failure. Then we send the promise with a failure. If it succeeds, we now have two values in our hands, the result of the first promise and the result of the second promise. We call the function here, and we're done. Okay, now let's look at how we define zip using await instead of promises. And here you see that this is, again, much more elegant, because what does zip do is we just await both of them, and then we just apply F. If any of them fails, the async block will take care of that. So this is, again, a little confirmation that I like this async await, despite all the problems that it has. Now, here's an example of a function that can only, that its nicest implementation is just using straight recursion, no async await, and no promises. And what this function does is it takes a list of futures and turns it into a future of lists. And the way it works is it just goes through that list and runs all the futures and collects the results into a list. And using pattern matching and recursion, it's quite easy. If the list of futures is empty, well, we return a future with an empty list, because we want to pivot the list and the future. That's what you see on the type, right? We want to swap list of future becomes future of list. So that's what we do here. If we have an empty list, we turn that into a future. And otherwise, we get a future followed by a list of futures. And what we do is we call the flat map of future. Then we get the value t. Then we recursively sequence the rest of the list, which returns a future of list. So we flat map that again. And then we return a new future, putting the first value there on top of the rest of the list. So this is quite elegant and nice. Now, I warn you, the next slide that uses async await is kind of grungy. So we have to kind of allocate a list buffer, do a while loop. This code is not beautiful. I'm not proud of this code. This code looks much more elegant. Okay? But notice again, straight recursion wins. It's the most elegant one. And using promises, I don't even know how to begin. Okay, so this might be something that you want to try at home, but it's definitely not going to be as elegant as this. All right, thank you very much. We have now reached the end of the left column of the 4 essential effects. So we talked a lot about trie of t, and we talked even more about futures. And you see that these are the effects that make computations that return one value explicit. So trie of t is a computation that returns one value that might fail, and future of t is the monad that expresses a computation that might fail and takes a long time. Okay? And what we're going to do next is we're going to switch from one to many, and then we're going to do the same sequence. So we'll first look at synchronous collections, and then we will go to asynchronous collections. But for now, thank you very much, and then see you next time when we're going to move from the left column to the right column. Bye-bye.